So
So
in the
guys,
next session at GroupBy, Steve Jones will be talking about bringing DevOps to the database. So take it away, Steve.
thanks, Brent. So welcome everybody. Hopefully you're having a good Friday here, and you're interested in DevOps and the database, and I'm here to talk about some of that. So I've definitely given this talk a few times, different places, and it's been fairly popular, and I always learn things, and I always encourage people to ask questions because it's always interesting to see how people view the world of development and what works well for them. And so the agenda really today is to kind of talk a little bit about kind of DevOps and software development and specifically database development, and just kind of level set us all in the same spot, and then spend most of the time kind of in a demo and try some things and show you some things. The one thing I want to emphasize really is that what I'm showing you is just a particular implementation of how you can easily move database development and have it go faster, smoother, easier, or anything you want. But I'm not trying to say you should do it this way, or I'm not trying to say you should use the tools, the platforms, the techniques, anything that I'm doing, right? The platform doesn't matter, right? Whether it's SQL Server, Oracle, or Neo4j or Mongo, it doesn't really matter. And source control doesn't matter, and all that stuff. But there are principles and ideas that we kind of want to follow. So who am I? I'm Steve Jones, and I run SQL Server Central. I founded that site, about 15, 16 years ago, and it's been my full-time job for about a decade, really. And then I worked for Redgate Software as an evangelist, but I've been working with SQL Server for almost 26 years now. I started back in 1991 on version 4.2 and actually ran SQL Server on OS2. So I'm now on my third platform running SQL Server. I've run it on OS2, on Windows, and now on Linux. So I've had a lot of experience in that time. I've worked with all the different versions, upgrading, typically, every few years, in some companies, some clients, something I'm doing. I've worked in big and small companies. So I've worked in large, 20,000 person companies, Fortune 100 companies, and then I've worked in small startups that were, 2, 3, 4 people, and a variety of companies in between. And I've had experience in different industries as well. I've worked in, in finance and education and utilities and import export, different industries across my career. So all my contact information is up here. Please, feel free to get a hold of me, and I'll have this at the end as well. So, if you've got questions, get a hold of me and, ask, and I'll try to respond as best I can. So let's talk briefly about what DevOps is. And really, it's this kind of amorphous thing that it somewhat defies definition. And it's kind of like saying cloud, right? What does that mean? And it's different things to different people. In some sense, the parts of DevOps aren't different than things people have doing for years. As a matter of fact, I would say a lot of the software development I've done throughout my career, 15, 20 years ago, was what we would call DevOps today. But it really, DevOps tries to encompass and just give us a way to talk about some of these good practices, these ways that smooth things out. Now, this grew out of the Agile movement, really. And in 2008, John Alspaugh wanted to do a talk where he had been looking at all this Agile stuff, and he wanted to do this Agile operations talk because he was an operations guy. And he went to a conference, and they accepted his talk, and he went there, walked in the room, and one guy showed up to watch him. So in some sense, it was a little bit of a failure, but in some sense, it was also interesting because he realized that he wasn't the only person that wanted to know. So in 2009, Flickr gave this seminal talk. John Alspaugh was part of this, and they had spent the last couple of years trying to become better at how they build and deploy code. And they gave this talk that said they deploy 10 times a day or more. And they do it by having Dev and Ops work together. Now, I've linked the talk in the deck. You can go watch it because it's interesting. But in 2009, 10 times a day, it was stunning. It was phenomenal. Nobody could really believe that people deployed that much code every day. And since then, we've seen it change, right? In 2010, Etsy actually did talk, so they deploy 50 times a day, and various other companies have come out over the years, usually these progressive high-tech software as a service or all internet companies that deploy many times. And just a few months ago, Amazon actually released statistics for 2016, and they deploy actually every 12 seconds on average. So throughout the year, if you look at all the deploys they did, it's 12 seconds. Now, doesn't mean every developer deploys every day, because they've got thousands of developers at Amazon. Doesn't mean that these are all, big changes or small changes. It's just a variety of stuff that happens, right? Could be somebody alters a CSS style slightly, somebody changes an image on a page, somebody makes a database change, or somebody updates a messaging queue, updates the contract that's going to flow through the messaging queue, or any number of things. The whole point is that they want to be lean and agile and flexible to be able to deploy when they're ready to deploy. So, if all of the people, so a bunch of us were just on here talking, if Eric decides he wants to deploy today because he's going to update, the main page on WordPress, he can certainly do that. Might be something he's worked on for a day. Brent might have a new Lambda function that fixes a bug he just saw this morning, and he deploys it, 20 minutes after he creates it. Could be that Tara has a database change that she's been working on for 3 weeks, and she finally deploys it today, and Dark launches it. The idea here is that we want to be able to move at the pace and at the schedule that works for us, whatever that is. Is it once a year? Is it once a day? Whatever. The other thing to know about DevOps is that it's not a specific thing. It's not prescriptive. So DevOps doesn't say everybody stands up at a meeting every day, that we only have teams of 10 people. It doesn't say any of that stuff, right? DevOps means that we try to follow these principles and ideas that help us build better software. And the way that we do those, the actual implementations, could vary from company to company, or project to project, or person to person. But it's similar to, or not similar to, but kind of encompasses Agile and Scrum and Lean and Kanban and Waterfall and everything else we've talked about throughout our entire careers, but do it in a way that helps us get better. Now, it's kind of been best expressed by Gene Kim in these 3 principles. And Gene Kim is a researcher. He was a CTO for Tripwire. He's been an entrepreneur and tech guy for lots of years, but he's been researching DevOps and software development for the last 6-7 years pretty heavily. And he wrote the Phoenix Project, which is kind of a DevOps story disguised as a novel. And certainly I'd recommend, if you want to get an idea of some things that you could maybe see going right or wrong inside of different companies or different organizations, it's kind of an easy, fun read. He's also written a DevOps handbook and a few other things as well. But he postulates that we've got these 3 principles that should guide us when we build a software pipeline, which goes everywhere from, if I say development on the left, I may have QA. I certainly could have architects and project managers and all these people on this side. I have operations. I could have security people. I have my clients, obviously. That whole group of people, where we want to think about them holistically. So we want to think about the entire system. We don't want to optimize development, right? We're not trying to just get development stuff done and thrown over the wall. We're not trying to optimize operations so that security is perfect. We're trying to optimize the flow of software so that everything moves smoothly to our clients at the speed that makes sense for our organization. The other thing we want to do is amplify feedback loops. One of the problems I've seen throughout my career in development typically is that feedback is difficult, right? Clients get upset, they complain, it doesn't always get back to developers, or it doesn't get back to developers in time, it's not smoothly. Operations people have issues, and all they do is complain when developers release code or when they have to deploy it. And developers complain and architects don't listen, or there's all these issues. And what we're trying to do is we want to make sure that we get feedback loops that make sense. So when QA sees issues with software, they can easily let development know and help them get better, and development accepts that. And operations can let people know how they need software built so that they can deploy it and so that it makes sense. And clients obviously have their own things. And over time, what we want to do is get better and better. So it's not just these big feedback loops, but as we become better, we want to amplify smaller feedback loops. So is this feature actually being used? Does this query perform well? We want those smaller and smaller feedback loops to get back to different groups as we improve our process. And then the last one is we want a culture of experimentation and learning. I'm sure, if we were all in a room, and I wish we were, we could talk, we have all had issues with software, right? Building it, deploying it, something else. We have problems, we make mistakes. That happens right now. We don't want to necessarily prevent mistakes or get so uptight about them, but we want to try things, see how they work, do minimal experiments, fail fast, and then fix things. We want to learn. We want to get better. One of the things I think is sad is that so often developers, operations, everybody, we realize things don't work well, we fix them, but we don't adjust our habits. We don't get better and better at what we're trying to do. So we make the same mistakes over and over again. See it constantly in security. We see constantly in code and server configurations where we're not improving a lot. And I think people here in the GroupBy and people that go to SQL Saturday in the past summit, you are way ahead of everybody else because you are starting to think about things and you do make sense, right? You try to get better over time, but so many people in our industry, so often we might try things, we might break them, we get worried, we get upset, we don't learn, we don't get better and better and better over time. And so what we really want to do is make lots of small experiments. We want these minimum viable products, not as an entire product, but maybe that minimal viable thing is just a section of our database. We want to change our indexing. We want to add a few fields for auditing, or we want to add some more instrumentation and extended events or some other way to better understand what we're doing. And we want to make small experiments, see how they work, then start to maybe improve them, change them, grow them to the rest of our application, the rest of our system. Now, Donovan Brown works at Microsoft. He's the DevOps PM, which I'm not even sure what that means really, but I like Donovan. He's a great guy, and I had the opportunity to present with him last year. And all the work that he's done with DevOps and trying to change Microsoft's world, he came up with this blog post and he put this definition down, which I think really is one of the best ones I've ever seen. And ultimately, the goal here in this quote is that we have to deliver value to our end users. That's what we're trying to do with software. We want software to work for the people that are doing it. We don't build software for the sake of software. We don't build software so we have perfect, elegant code with the minimum number of lines or the fewest reads in a query. We have to deliver value to our end users, and that's what's important. Now, we can do it with people, processes, products. The proportions of it could vary. The choices we make, which people, how we change our process, which platforms, products, tools, et cetera, we use. That's completely up to us. But we have to put those together to make sure we're delivering value to our end users. And ultimately, that's the goal. And that's what I want to see, is that we focus on delivering something to our users that works well. And one of the things I like with this GroupBy, Brent's trying to change the conference world because we want it to be better, right? We want to deliver something to people. It doesn't really matter who's speaking, how are we making money. It's about, let's talk to people. And that was our goal with SQL Saturday. That was our goal with SQL Server Central, that we want to deliver something that people can use. And in DevOps, what we're trying to do is do that in the software world. So if that means, bigger servers, we scale out, we change platforms, we buy some tools, whatever it is, we have to deliver value. Now, Microsoft's come up with also some practices here. These are kind of ways that you might look at DevOps in practice, right? We do CI/CD. We certainly instrument telemetry and stuff. We manage configurations so that we're sure what servers look like, all this kind of stuff. In testing, I always hesitate to ask people how they test their code, or do they test their code, because most of the time I'm sorely disappointed in how people test their code, and it shows, right? We all see it in the end product that gets to end users, that's delivered. We certainly see it at times from Microsoft and other vendors when they deliver it to us, that we're like, God, please test your code more, okay? It's important. There's also habits, right? There's habits of how we as individuals, we culturally have to work together, that we have to be sure that things start to align so that we're all trying to deliver that value to customers. And these are kind of examples of things that you might do. And certainly it's not just developers, not just operations or that group. It has to go to everybody, right? Managers and project managers have to be trying to deliver value, not just get something done or not just deploy something. We have to kind of make sure that we are actually delivering value throughout the organization. And certainly this requires buy-in from management. I know DevOps is a hot topic now, and lots of managers want DevOps, and they have no idea what they're trying to do. But ultimately, it's as we try to move to a DevOps culture, we have to change the way we work, the way we manage people, the way we put things together. And I'll say, as I talk with clients and work with people at Redgate, the hardest thing for most people is the culture. The technology stuff is easy. It really is easy. The cultural changes, building trust and acceptance and sharing information and communicating and taking ego out of it, all those things are incredibly difficult. Now today, really want to talk in practice is the first three things are the technical side, right? We want to do automation, and I want to show you some automation. Certainly testing is a part of this as well. We want to instrument things, and there's all sorts of ways to instrument. And I don't really want to get too detailed into that because that's a whole nother talk, and that just goes, sideways. But those last three items are the important things. We have to communicate with transparency, and we have to share information, and we can't try to make my job better than your job or more important, right? We have to ensure that everything works well. So let me talk briefly about software development here. So some of you are application developers. Those you are, raise your hands. Brent can count them. I'm not going to. But as we're developers on the right side or the left side of this, right? Developers typically work in version control. We're in Visual Studio or Eclipse or IntelliJ or whatever it is, and we write code. We store it, commit it to version control. We pull it back. We share code. And then the more advanced developers, and I wish this was most of the world, but I don't think it is, should be doing continuous integration. They'll actually commit their code and have a system automatically build and test it. Now, continuous integration grew out of this idea that a long time ago, back in the 60s, when IBM was building System 360 and VAX was building their systems, we realized that if we took really more than like 3 people and we put them in a room and had them write code for a month or 2 months or 3 months, and then we tried to put it together, it never works. It just never works. Some of you have probably read the Mythical Man Month, and if you haven't, you should, because that really highlights it, that we can't build software better when we're working separately and not coordinated. So some companies in the 80s and 90s started to go to a daily build where they built their software every day because there's only so much damage each of you as a developer can do in a day. And so at the end of the day, we compile our code. If it doesn't work, we fix it. And nobody goes home till it's fixed. Well, as hardware has become more powerful, we have virtualization and containers and all these changes. People came up with the idea of, why don't we build on every commit? And I think ThoughtWorks and Martin Fowler were some of the first to do this, where they said, every time we commit to version control, let's pull all the source code out, let's compile it, let's run automated tests against it, because we can't trust developers to run tests. And then let's let the developers know if there's a problem. And if not, let's package that as a potential release candidate. Let's publish out an artifact that is an exe or DLL or jar file or whatever that we can potentially send out to production. And so the idea is we've introduced some automation and some consistency in our software process. And then what we want to do is we want to use that artifact and we want to put it into a release management system so that we deploy it in the same way every time. That if QA pulls a build of our software, right, whether that's web software or backend software or client software, they get it the same way that we'll deploy it to beta testers, and the same way we'll deploy it to production, that we have everything working consistently. And that's ultimately proven to be one of these ways that companies can move faster and produce better software. And Microsoft does this, regardless of how you feel about SQL Server. It's stunning that they're going to release a new version in about a year, right? June 1 was SQL Server 2016, so we've got a few weeks. They could actually hit a year. But the reason that they can do that is that they are constantly building and testing, hundreds of thousands of tests on that platform, and deploying this out in a smooth fashion so that they can actually deliver software faster. And they started this back in 2000, where they realized they had problems with patching, and they started to do regular patching. And certainly Windows does this. Lots of companies are starting to do this, but it's having a smooth pipeline means that I can build and deliver software better and faster. So what about database people? Right now, typically we have the databases we work with. Maybe we each have our individual one. Maybe we share a database. Hopefully we communicate with other developers. I think the worst thing I can see is for database developers to kind of work independently and not talk to other people about the changes they're making, because ultimately the database is kind of that central point where we all meet often, our applications or our systems meet. So we have to communicate. But we typically haven't had version control. I've worked with Oracle developers and DB2 developers and MySQL developers and SQL Server developers, and so few of them have version control. And they certainly don't have any continuous integration. They don't publish any packages out. But what they do is, at some point, everything's in some shared database, which could be development or it could be QA or something else. And then the DBA is responsible for figuring out how to deploy that to test systems. And then they have to refigure out how to deploy it to user acceptance or beta systems. And maybe they refigure and they deploy it to staging before they deploy it. And maybe they had to fix that one little thing, I can make this work a little better. And then they make a new script, or they alter their script and they deploy it to production. And it's inconsistent. And many of you are very good at this. I don't mean to disparage you and say that this doesn't work, because most of my career I've done things like this. And I've had a lot of successful deployments. Right? I get stuff done. We deploy software. It's just not the greatest thing, right? We make mistakes. We realize I forgot this script. We forgot an object. We didn't do this thing. We didn't set permissions. Any number of things happen when we're dealing with databases. And those problems lead us to be nervous about deployments. Most companies I've worked with, most database developers I've worked with, they try to limit how often they deploy to the database because it's stressful, right? If it goes down, it causes problems. Everybody's upset. Typically, we're bundling in more objects, right? More changes because we've waited a while, and then that makes it more complex and more risky to deploy that. It doesn't work. So then the next time we try to be more careful. We try to, put more process and paperwork on it, and we end up delaying and our deployments more and creating more and more risk all the time. We don't want to do that. So what I really want to do is we want to evolve database deployment to be more like application developer, because the application developers have gotten better and better and better at building software over the years, right? Still make mistakes, but I'm stunned that all the apps that I have on this thing here, right? They update regularly, right? Not all of them, but some of them across all these apps. Some of them will update and they get pushed out, and they relatively rarely have bugs. I remember deploying client server apps and 3-tier apps, and they constantly had bugs. So we've gotten better, and we want to do that in the database as well. We want to get better. Now, I'm going to start with version control. So I really start from the left and move over. So I'm going to go from developers to test to operations, right? Pushing the code that way. But ultimately, we build this process the other way, right? We've got to understand, what do I need to actually deploy software, right? How do I get these changes into my database? So I've got to think about that process, and then that drives what I need to output from my CI system or from an intermediate system. I've got to know, how do I put that together so that I can deploy it? And then, of course, knowing how I'm going to put that together will drive how I store things in version control. Now, most of us, we try this, we'll start with version control, we'll realize it doesn't quite work, we'll change something, we'll get that working, we'll go to deploy it, realize it doesn't work, we have to then go back and forth, and that's totally fine. That is, we just want to get better and better over time. So we want to use version control, and I'm going to start there. And ultimately, that means I've got to get my code into version control, and that's challenging because unlike an application, right, if I have a C# or a Java class, right, I've got the class, I've got the properties, I've got the various methods in there, and they're all in one file, right? And I have multiple files here that I store. But in a database, everything is separate and it's on the platform, right? If I'm an Oracle or SQL Server, MySQL, the table code is kind of one way, and it's really metadata stored somewhere, and my views and store procedures are code somewhere else. And so I've got to manage those together. Now I'll talk SQL Server because that's where we are, but the ideas are simple in other platforms, or sorry, similar in other platforms as well. I need some way to script and gather any DDL that I have out there, and potentially DML as well, because part of our deployments, part of our software can involve DML, right? So we'll talk about that. At SQL Server, I can use the SMO interfaces and do scripting, right-click, generate scripts, connect with PowerShell or something else and generate scripts. Certainly that works. Third, there's a few third-party tools out there. Redgate makes one of them. I'm going to show that today, but ultimately, all of these tools or the scripting really boils down to, it's doing a file save and a file open. So I want to file save all of my object code into a file that I can put in version control, because version control deals with files, not with database platforms. And the same thing, I could certainly pull code from a version control system, do a file open and edit it, right? Rather than right-clicking something in Manage Studio and saying modify. I could certainly just file save and file open all my code. And I could teach any of you to do that in about 3 months. And I've done it before, right? I can take developers, database developers, app developers, whoever, operations people, and it takes about 3 months to build a habit that I always file save and file open my code. But that's ultimately what we're trying to do. And however you want to make that happen is up to you. Like I said, I'm going to show one way, but you do whatever you want. The other thing you have to think about is, how do I organize this in my version control system? Now, we have some clients and customers at Redgate that use separate repos for their application and their database, and some use the same repo. And it doesn't matter ultimately, okay? It doesn't matter what you want to choose to do. Some people want application changes and database changes to commit together so that they know this is a deployment unit that I'm going to send out. Some people want separate. Now, I prefer separate repos because I want the database to be a first-class citizen. Because if I've got a web app to connect to my database, it's not going to be long before I have reports, or I have Excel, or I have some ETL extract or something that's going to be there as well, which means then I have 2 applications on one database. And rather than just get confused, I like to have a separate repo, but you can make your own choice, whatever works for you. The other thing is, don't put all your files in one folder. I mean, I know if you script it out of SQL Server, they'll all be in one folder. In a database of any size, it gets incredibly confusing and cumbersome. So I just separate them out, right? Whether you use SSDT in Visual Studio, use the Redgate system, something else, usually we separate things out to tables, views, store procedures, whatever. And when I've worked manually and built my own methods of scripting things out and building packages and deploying them, I did that as well, right? I have table code, I have view code, I have store procedure code, all that stuff. The last thing is use pull requests. Database changes can be disruptive. They're inherently more risky than application changes. So please don't develop in your main branch. And I'll show you that today. Have a branch where you do some development, you test things, you try them. And when you think things are okay, use a pull request to merge things back together, or the equivalent process in your system. I'll use Git today, but you could, even if you're in SourceSafe, you can essentially create your own pull request and have people move code to a different branch and manage it that way. All right, so let's look at some demo stuff. We doing all right, Brent? No questions? Still
totally
awake?
Doing good. Yep, totally
right.
Doing good.
All right, so let me orient you a little bit here and what I want to try to do so that we have some idea. I've got this database here that I'm going to do development in, and apparently I can't click my control key, but this is essentially my development database. So this could be on my laptop, my workstation, could be on a shared server, whatever it is, but this is where I'm doing development. And my recommendation is typically every developer has their own spot they can do this so that they don't mess with anybody else. And, it's driven me crazy in the past when somebody, changes a table and then my queries break, and it's disruptive and annoying. So I'm going to make changes here. And then what I want to do is I've got a, stupid keyboard's not working. I've got this integration database. And what I want to have happen is once we pass all of our automation testing, I want to push those changes into this integration database. So, typically, like if Grant and myself and Arnie and other people at Redgate, we're all developing in our own databases. At some point, we want to put all that code together so that we can see it with the application and make sure that we haven't fundamentally broken anything in development. And so typically we have some sort of integration database that has all of our code together. So this is the second place we'll put stuff. And then I've got a QA database. Boy, this Vio keyboard does not like to, I think I broke my control key.
It's a poor musician that blames his instrument.
Exactly. So the third place is we want to send stuff to QA, right? Where humans can look at it, because there are certain things that you can't write tests for easily, and it's good for humans to do it. So we want a different place that, we can just deploy database code to, and somebody can then look at the application, whatever they want to do. So those are three things. And the other thing I want to point out is this is on 2014 that I'm developing, but I'm using generic code, so it doesn't matter. Once I've deployed it there, I've actually got down here a 2016 instance. This is my staging place. And this is where I want to perform one final deployment test before I go to production. So I'm going to take this code that we've developed on one platform. We're going to shoot it over to this other platform automatically. Not, I got no sleeves on today, so I'm not going to change that code. It's going to go there automatically. And then if the gods are with me, we're actually going to deploy that code out to Azure, to database.windows.net, right? Which is roughly 2016 and a half right now, I think, 2017.8, whatever, however you want to view the world. But we want to send that stuff out there, and actually, I went too soon. This database is where we'll shoot this stuff, this demo database. All right, so that's where we are. So let's start here. So I've got this development database. I'm on my local machine here. Let me create some table here, because that's good. And then let me do some stuff. Actually, let's change this stuff here. So I've got this table of country codes. Whoops. Let's do this way. It's got all the country codes, typical kind of lookup reference data stuff. Let's add a value here. And let's call this, since I have Brent hosting. What we should PR, no, just POR. That's probably not a country, right?
911. 911.
911 is a good code. That's it. That's a good one. All right, so live and in color, we're doing this. And then a lot of times when I'm testing things, actually I have a client there that wants to, they went to weekly deployments of the database. So they went from literally like every 2 or 3 months to weekly deployments. And they don't always deploy stuff, right? They don't always have database changes, but the DBA really wanted to make sure that they could just deploy something, because it builds confidence and people can see things are changing, and that way they at least know that the process still works. So one of the things talked about is just deploying, you make some complex code, but something that's not too crazy, that's not going to affect the application. So a lot of times what I do is I make these really interesting stored procedures that let me just test if stuff is working, right? Is my deployment working? So if I run this, this should work, right? And let's change this to say entry code is equal to 911. So that exists there, right? So that kind of stuff exists there. And let's actually just change this to like get 7. Sorry. I know I shouldn't type in demos, but I want to.
It works.
It works. Right, so I've got this code here, and if I jump over here, here's my integration database, and let's execute some stuff here. I don't have that row, and obviously that store procedure doesn't exist. And in my QA system, that doesn't exist either. Got all kinds of issues. In production, production's always red, right? That doesn't exist there. You know, so I haven't deployed any of this stuff out there, right? No magic here. I'm not gonna do anything. Everything's gonna happen in front of your eyes. So let's commit our code to version control. So again, this is a Redgate tool that just plugs into Visual Studio, but all it's doing is it's grabbing my code. So in my country codes, right, I've added this new row, right? We're gonna have Portland here. My incredibly impressive store procedure is here. My ratings table is here. All we're doing is just taking this code that you see on the right-hand side or the left-hand side, or the right-hand side, I don't know, whichever way you're looking at it, on the one side. And we're going to put it in version control. We're just going to put it into a file. So this is group by demo changes. So the comments that you write in version control are there so that next week when I look at this, I'll have some idea of what I did, right? That don't matter. I have these changes that I've committed in there, right? And all I'm doing is sticking them into a file, and they actually exist. Let's come here and let's do something and say, where's this? /visual, DLM, /t, no script, /t, there. Right, so I've got this stuff here. And one of the things I did was I created this ratings table. It's right there. So we just did that. That's now, it's the 28th of February or April, wherever we are. I don't know. It's 10:30 a.m. in the mountain time. That's just a file we just created. That's all we did. And we did it in our auditing branch. Oops. Let's come over here. Auditing branch is there. I'm clicking on the wrong thing. Hi, that's me. And I'm going to push this stuff out. So I'm going to push this out to a remote repository, a version control system. Now I'm using Git, and that stuff actually is going to exist out here in my Git system. And I'm running on Visual Studio Team Services at visualstudio.com. Here is my URL, which none of you will get access to, but that's all right. You know. So I've got my, I've just committed a minute ago. I've got my store procedure, this amazing change that I made right here, my get 7, my table, my data changes here, all this stuff is there. And you'll notice that this realized I committed a branch change. Do I want to create a pull request? And I actually do. Now I should test this. I should do some stuff, but I'm
doing it live.
We're trying, yeah, it's live. We're trying to get through this in an hour. So we do have clients that do this exact process. Some of them use GitHub, some of them use Bitbucket, some of them have internal Git. I don't know if I have anybody personally using Visual Studio Team Services, but Visual Studio Team Services is fantastic. Once they got to TFS 2015 and better, update 2 and better, this is the first time I've seen a Microsoft development tool that I thought was excellent. Most of the time I think they're, this is fantastic. So like I said, we have clients that do this. They create pull requests. And what they typically do is then they have, a bunch of them have 2 people review the code. So they would come in here and they would look at this code and they would say, all right, they're going to approve it since I'm in charge here. And I'm just going to go ahead and prove it and I'm completing it. And you'll notice, if it's related to a work item I've got here and stuff, I could delete the branch. I could do all the crazy stuff that I want to do, but I'm not doing any of that stuff. So I've created this and I've actually merged this into master. And so if I were to switch to master, we'd actually see that I've dropped this code there and it's available for everybody to see now, right? And those of you application developers might be familiar with this, create a branch, do some stuff, test it, get somebody to review it, and then merge it back somewhere else. Typical flow in development world. All right, so we've gotten our code there. Any questions so far? Usually we're asking people if they're interested.
I mean, it's stuff that's not necessarily related. There's, for example, you can only do so much damage in a day. They say sounds like a challenge. But Scott says, does Redgate recommend putting your agent jobs, instance configurations, data, like when you make SP configure changes as part of a deployment? Would you also include that as part of your source control?
Yeah, so from the Redgate perspective, we don't really work outside the database, right? Everything we do is self-contained database. And I wish we did more. The answer for me as a software developer is yes, put all that stuff in there. So as an operations guy, when I used to manage in a finance area, it was really important that stuff worked. So, if we changed, this, so back in, we went from 6.5 to 7 to 2000. And so in the 6.5 world, man, if we grew a database, it was ultra critical that we knew what the additional file and size that we added mattered, because I had to recreate that on restores. So we put that stuff in version control. It's like, dude, that database, I have to know every single change that ever happens. And if we do something like we're going to change parallelism or we're going to change query timeouts, nobody ever gets to change that in the GUI. As a matter of fact, if I were to come over here and say on my server, right, that I want to do something crazy, let's do something easy that I won't break, hopefully, stuff. Like I want to come over here and I want to go, I'm going to change this to 11, right? Which is, if you guys want to do this and try it in your production servers, BrentOzar.com is the place you're going to call for help when
just
everything
$9.95.
all performance goes down. They'll fix that for you, right? But this button right here, again, it takes about 3 months. I taught all my DBAs, if you press this button, you're fucking fired. Excuse me, you're gone. Right? You're not. You get to press this button right here.
It teaches you so much.
Yeah, you press this button and then you go, okay, what exactly am I doing? And then the first thing you do is you come up here and you press this button right here. Because when you screw things up and stuff stops working, I want to know what you did. And believe me, it takes a few months of me screaming at people for them to understand that I'm serious about this, that you log everything you do in the world. And part of DevOps is instrumentation and telemetry to understand exactly what happened at any point in time. Not so that we blame people, right? If you make this change, we can talk about why it's a good or bad idea. But if you make this change without telling anybody, without logging it, without anybody notifying it, that is the problem. And that's what I try to do, right? So anything that's a change, let me get rid of this before I break something horribly in my system. Anything that's a change, right? If I do agent jobs, if I do extended event sessions, if I change queue addresses, if I'm doing containment, if I'm parallelism, adding file groups, all that stuff gets logged in version control, always, always, always. Now, think about how you're going to deploy that. And I might recommend that the ops people have a separate pipeline for non-database changes that they want to deploy, mostly so we're just aware that they at least went to one other environment so we can test that they work, whether or not they have a performance impact, just the fact that running the code works. And then we have a log that says we deployed this to production on this day and this is what ran. So that's my answer there.
Perfect.
All right.
There's a few others, but they're not quite related, so I'm going to hold on to them till the end.
Okay. All right. So let's keep going. So let's talk continuous integration now. Now, the idea, as I said here, is right. We want to compile our software. We want to test it. We want to publish out some package, and we want to let developers know if something's broken. Now, there's many ways to do this, but we have things called CI servers or build servers, and these are server processes that are designed to build software. That's really it. They're like fancy SQL agents they just execute steps in order, and they build software. So they understand how to run Ant or Nant or Maven or Make or anything else to build software. And so you can use whatever you want, Bamboo, TeamCity, Cruise Control, Hudson, Jenkins, TFS, whatever you want. I don't recommend one over the other. I'll say that, I've used TeamCity quite a bit. I've used Jenkins and I've used TFS. And I think Jenkins is it's painful, right? It works perfectly. Tons of people use it. It's free. It's just painful for me to use. TeamCity I really like, and I like Visual Studio Team Services or TFS. Once you get to really 2017, it's fantastic. So pick one of those. And the process of compiling code, right, for databases is we have to get all the code from a version control system and then execute on a database and execute in order, right? So I can't build indexes before I build tables, right? I can't typically, alter tables, after I change a view to add a column or, have something in a stored procedure. So there's an order to how I execute database code. For a particular application, for example, if you have one database and one application, this is trivial code to write. I mean, honestly, you could just say, run table 1, run foreign key 2, run, store procedure 7. That's trivial code. To do it for multiple applications and kind of generically, it's more complex, but there's tons of tools out there that will help you do this stuff. So, that's what you have to do, however you want to do it. Okay, I'll show you. Redgate has a tool that does this for me, but I'm not advocating that, right? I'd love you to buy Redgate products, but there's plenty of ways you can do this. To test your software, we'll talk about that in just a second, but you got to test your software. Please, please, please test your software. And then you have to publish out some package that's potentially an upgrade script. Now, in the database world, we don't get an exe or a DLL or an assembly or a jar file or a module or anything else. We don't get that thing because when we compile code, it exists on the server platform, and we can't extract that binary code out, right? We just can't do that. So the way we publish a script in the database world typically is I want to grab the state of all my code in version control because that's what my database has to look like. And then I have to figure out how I execute that in the future. And there's a couple ways to do it, but we'll talk about that when we go to release. So that's what we want to do here. Now for testing, if you've ever had somebody send you a bug report and say that something doesn't work, you should be testing your code. I mean, even if I'm not advocating you to sit here and start a project and write tests for all your code. Please don't do that. That's silly. But anytime anybody tells you something that doesn't work, you forgot a foreign key, you don't have a default, you don't have anything else, write a test. It's that simple. Just start writing tests for the things that you don't do well. And your users and your QA, they will tell you what you don't do well. So write those tests. Again, there's plenty of frameworks to do that. Some of these frameworks are built for databases, and so they make things easier to do in the database world. I'm actually using T-SQL-T here, which is an open source. I think it's open source. It's certainly an open free project, but you could use DB-Unit, or T-SQL Unit, or PL-Unit, or there's any number of ways. You can write your own tests. The only thing is they have to be automated. I have to be able to run one command or push a button, and it runs all my tests. That's the only thing. Because I know a lot of you want to go, I write a query, I insert data in a table, and I write another query, and I've tested my code. And that's not a good test because it's not repeatable, it's not reliable, and you'll forget. Use a framework of some sort, XUnit, DB-Unit, Microsoft MS Test, I don't care. Pick something and use it. Now, we have plenty of customers that use curated data sets, and they have fantastic results. We've got a customer that deploys code to multiple countries, and before they started to do a process like this, and before they started to have curated data, they constantly had issues, right? Stuff would work in English and it wouldn't work in Italian. And what they went through is they created curated data sets in all their localized languages. And for them, it was really go to production and take 10 rows from every table, right? I mean, the list of countries, take them all, right? List of postal codes. But, for transactional data, take 10 rows that represent your application, right? Everybody probably knows, I've worked with accountants and they can go, there's these 7 clients that they have all the weird accounting stuff we have to do in the GL. So if your software handles these guys, great. And then what you do is you realize, well, there's really an 8th customer. You just add those rows of data, and it's a project. I mean, it's something you do as part of development. It's maintenance work, but it really does help. We have customers that write between 4 and 10 times the amount of test code as they do database code, and that includes maintenance, but they almost never have deployment issues, and they almost never have bugs reported by clients because those tests define the requirements that clients ask for. All right, enough. We could talk testing all day, but let's do it. So let's talk about continuous integration. So one of the things that happened, I deployed that code, and somewhere I have an integration thing here, right? We ran this a little while ago, right, Brent? We ran it well, and this code wasn't there, but now it is. Because I had continuous integration running in the background. Now it's not in my QA area, wherever QA is, because that's still broken, but it certainly got deployed to my integration environment. And so how did that happen? Well, what happened is in the background is I had a continuous integration, those are big words for me. I had a continuous integration process running. And so I'm actually going to kick that off again so we can see it run. And again, we're going to use, if you don't understand this code, message me later on Twitter and we'll explain it to you. But we'll make another change. I did that there. So let's commit this change. Did I change databases? I did. So I'm an idiot. All right, GroupBy demo 2. So I have another store procedure. I'm just added in there. I could alter stuff or do whatever if you want to see that, but we'll do that. We'll push this code out. And again, we'll pop back over here and we'll do a pull request because one just created. Nice thing about TFS is it kind of thinks ahead for me in some ways. It tells me. The bad thing about Visual Studio Team Services is that they change stuff. So like this stuff on here moves every like 3 or 4 months. And so if you're not in here regularly, it can get confusing. So I just completed this pull request. I just merged this into production or into master. And actually what I have is I have a build actually running here. So we'll see something happen in a split second here. And if not, I'll come over here and look. So I've got these builds set up, and you can see, in fact, one is in progress. Where's my one? One is in progress here, but I've had numerous other ones that have been running in my system. And if I were to look at this, I could actually see this running. So I have an agent process running that I could have on any server in my data center lab or whatever. And the agent would, it's downloading the code from Visual Studio Team Services, and it's performing the build and the test, and it's going to then, it sends results back up here. And so this stuff that's happening here is exactly what I'm seeing happening on the web. So I could have this happening on one of my other servers here and running, but in this case, I've just got it running all on this one machine because it's just slightly simpler for me to demo it and show it all happening, right? So this is actually running. And if I look back at my builds, you'll see I've had some good success lately, but these are just steps in assembling software. So I go get my code from a repository, right? I'm getting it from the master branch. I could get it from release branch or dev branch, whatever. I build it, right? And this is that simple thing that I said. I execute my .SQL code in order, my tables before my stored procedures. Maybe some functions have to come first and views later, other stored procedures later, indexes. I just do it in order. In this case, I'm building on my local system here. I'm going to run tests here. My testing step is actually fairly simple. So here's my original database. Let's just create a new window. This is actually what my testing step does, right? I have a lot of configuration to say do this, and I'm running tests. And in this case, I actually have a test failure. Hopefully you all know that tables have primary keys. They should all have primary key, always, 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 always. Unless you can prove to me they shouldn't, but in general, always. Then I'm going to sync my integration database. That's right here. So what I'm going to do is I'm just going to upgrade it with all the code if I've passed tests. And then I'm going to publish some artifacts out. And so when I look at my builds, I can see what's going on. So 446 just succeeded. And when I look here, I get all the telemetry, right? I see all the steps ran correctly. I can see what's going on. In this case, maybe I didn't have a test here that's failing on my dev database, but I've got all my tests here, right? And I can see what's going on. So I can follow through as I look through all my builds and see what's been happening. Is something broken? And typically if something breaks, this is where I want to message my developers or message one developer and say, hey, something's broken, go fix it. Because part of the idea in continuous integration is I want my main branch of development always releasable. Because if we find a bug, I've got to be able to fix it today. So I can't have like 12 things that are half done from other developers in there. It's why I work in branches. But I have the ability to, if I find something broken, I either got to fix it immediately. And one philosophy is everybody goes and helps fix that bug right away. Or I go back and I revert that commit and I get the old code in there so things are working, and then I test it further. So in this case, I've got this running, I've got my build running, it succeeded. So I've actually upgraded that database. And so if I were to come to my integration database, and let's copy this code because that's always better, I should have another stored procedure in there that's automatically deployed there. All right, so I've gotten that working. Right now, I didn't really implement it, right? It was already done, but essentially I just went through here and I said, give me steps. So if I wanted to add something else, you'll notice here on the right, I've got all kinds of tasks, right? So I could add a .NET Core task if I was trying to build this with an application, right? I could do, just my own batch script, some kind of command thing. If I wanted to use make, I could certainly be using make or Maven. I could use Docker. All kinds of things out here are available. And I just add these one at a time. For example, if I had a shell script, I could just add this over here and it appears here. And then I just have to configure it to do whatever I need it to do. Right? I'm going to discard this change because I'm not that brave to do this in a demo. But I certainly could have a Visual Studio build or something else if I wanted to. All right. Any questions? Everybody
Yeah, there's one when inside the Redgate tools. How does it differentiate the difference between lookup data that you're adding for like your own personal tests versus things that need to get pushed up into source control? Is there a way to say these changes I don't want to have as part of my pull request or what goes into source control?
Okay, so let's look at that two ways real quick. So let's talk about generically. So let's take Redgate out of it because really it's a generic process. How would you differentiate what stuff needs to be tracked and what doesn't? So if I look at this list of tables and I look through here, I have to have some knowledge of my application to say, well, articles and blogs, these are not lookup data, right? This is transactional data that will be generated in production by the clients and the workload and all that stuff, right? My auditing data will certainly be stuff generated in production. I want to track that separately. But then I can go, this country codes, my postal codes, my, list of currencies, this is lookup data. So how would I track this stuff and get this from development to production, right? Well, there's plenty of ways to do that. I mean, certainly I could say, well, I know that we did something like this, right? And I can go, well, that was a 1, and this is the wrong table, right? Mm-hmm. This is exactly what you do, right? You'd sit there and go, well, that was wrong. Yeah, you do this, and I'd say, this is Portsland, and this is 911, and then I'd save this, and I'd say, updated country codes 2017 04 28. And then what I do is I'd have to then have a script in my process somewhere that says, oh, grab this and execute in the next environment. And if I change the name, then I'd certainly have to go, well, really what I meant was update
if exists
where, right? And right, as Brent said, I don't want to, if I was going to do this, or if I had the insert, right, if I was back here, I don't want to run this multiple times. So, I'd have to make this idempotent. So if not exists, select, then do this, right? Mm-hmm. So that's exactly how you have to do this stuff. Now, in the Redgate tool specifically, what I've done is I've just linked things as static data. So we have the ability to say, if I have a primary key, I've got 2 tables linked as static data, and all the tool does is go look at version control, go look at the table, decide what data is different, and then generate the script I need to do that.
Perfect.
Right. I mean that's what it's doing, but it's all that the Redgate tools, or really any tool you buy, are doing is they're doing the stuff you would do manually. So think about how you do it manually and decide, is it something I can write, and do I want to be in the software development world of checking data, or do I just buy a tool that does it for me? But if you buy a tool, you better understand how it works, because it's kind of important, right? Because every tool is going to have holes and it'll break. You want to know how it works. But that's how you're doing data. Where are we at time? Let me keep going because I'll run out of time. We'll do more questions and all that stuff.
Yeah, go for it.
So let me keep going. So the next part of this is the release side of things, right? I've got code in version control. I've tested it, built it. How do I get it to other environments? And really at this point in the database world, we have to generate an upgrade script. And this is complex because the SQL language is horribly broken, right? My alter table code looks fundamentally different from create table code. Completely opposite from Java or C#. My class code and my methods and stuff, that always looks the same, right? There's no alter class, alter method stuff, right? Always the same. In SQL, we're horribly broken. Now, we have creator alter in 2016 and later, which helps, but doesn't help tables. And there's still weirdness. And my table isn't a thing because the index is kind of separate, but kind of not. And my foreign keys require links to 2 things. And it's difficult. So you have to think about this. Now for code, we typically get the latest version from version control somehow, make sure the creator alter is there, write an idempotent script, do an if exists, whatever I want to do, and execute that. And in this case, it's easier because I can kind of go forward and backward if I have to. For tables, I really need some way to transition a table because I have to maintain state. Philosophically, there's 2 ways of doing it. I can use comparison technology, which is like SQL compare from Redgate, or what SSTT does with backpacks. And I look at the before and after, and I figure out what the differences are, and I generate a script. Or I can use what's called a migration-based philosophy, which Liquid-based, FlyWayDB, ReadyRoll from Redgate, Rails migrations, entity framework migrations, all these things do is they tend to track the scripts as we make them. So if I do an alter table, we track that as script 47. And then if I do a create store procedure, we track that as script 48. And then we execute those in order. And we track them and all that stuff. So those are just, there's two philosophical ways of doing things. Neither one's better than the other one. They both have good points and bad points. They have advantages and disadvantages. I prefer migration frameworks, but comparison stuff works great. Use whatever you want. For deploying the code, what we want is just like CI, I want a consistent process. And so I want to automate as much as possible because you as humans are not repeatable and reliable. Can't trust you at all, right? You may do something perfectly 100 times and 101 you'll screw it up. And that's the day we have the Black Friday sale and everybody's upset. So I want a process. I want an automated process. I can have manual steps if I have to, but I try to avoid them. And then I constantly improve my process because I'll find, I may deploy the same way all these times and all of a sudden I need to, do something different, right? I need to change security. I got a client that just went from SQL to Windows security. They had to change all kinds of things in their process and figure those out. So they had to improve their process to handle that change. I say use a release management server because this is a server process that just understands how to deploy software, right? It understands copies and deploys and logins and all that kind of nonsense. And again, there's tons of them out there. Use what you want, but we're just trying to do that. People always ask about rollback. I don't want to get into it too much, but in general, for code, you just get the previous version of your code and you can deploy it. Now, it logically still has to work, right? But you can just kind of move code. For tables, you're gonna have to have custom code because some things, like if I've done a merge, I might not be able to split data. If I've added a column and any amount of time has passed, especially in an online world, I may not be able to just drop that column. I may have to do something different. In general, my recommendation, I try to dark deploy stuff as much as possible. So I want to deploy it without the application using it or needing it or worrying about it, and then turn that on. Even if it's 5 minutes later, I want to be able to deploy the database separately, which means architecturally, I just have to think about software a little bit, but you can do it. The other thing is somebody asked a question earlier about what about other data that's outside of the database or stuff that might vary by environment. You can use kind of pre-post scripts, deploy once scripts. Ultimately, there's no great way to do this stuff. There's variables in release systems. There's tokens I can use, but really at this point, I'm depending on somebody to type something correctly into a place, a variable or something. And then I'm hoping they haven't typoed it. Now, I can test a process that says, in QA, here's the email server name, and did it replace the token and deploy that correctly? And in production, I assume that process will be the same, but I'm not actually testing the data piece of that, what's going on. So that's tricky. So let's do a release real quick while we've got time, and hopefully this works. And let's go to releases.
Now, you've got up to like 90 minutes if you want it, right?
Oh, okay. Okay, good. Yeah. So then I don't have to worry.
Yeah.
All right, so here's all my releases. Now I've actually got 2 pipelines here, and you'll see I've got different numbers of environments here, and sometimes it works, sometimes it doesn't. Sometimes I skip environments, sometimes I deploy all the way through. It's up to me what I'm doing here. Let me start a deployment here while I've got a second. And there we go. So here I'm picking a build, which this tracks back to these builds. Let me go look at what our latest build was so we can see. So 446 was the build here that we did. So I'm picking 446. You'll notice my QA department has an automatic deployment. My other ones don't. Those are manual. So I'll create this, and this will start deploying. As a matter of fact, when I look at this, I should see blue here somewhere in a second, and I do. And in fact, it's going to start deploying here. It's downloading. Once again, it's going up to Visual Studio Team Services, pulling down code. It's looking at that package that came out of CI, and it's starting to unpack it and look at it and figure out all the stuff I have to do to deploy it, right? That's what's happening here. And the way this works is very similar to a release process, or sorry, a build process. I've got environments, so I've got multiple environments here. In this case, I've got 2 steps in here, and I configure them, but these are just steps that I could add. So if I wanted to add some step in here, like if I was going to deploy this to an Azure App Service, I could do a deploy there. I could do an RM deploy if I wanted to. A resource group deploy. I could do whatever I want, really, right? I could upload to a mobile center. it's crazy what you can do. And the nice thing about Visual Studio Team Services and really all the platforms is, they'll deploy to Linux and OS X and, do iOS and Android deploys while they're doing your web deploy to AWS or Azure or whatever, or to your own thing on site. I'm deploying to databases on site here. That's what's actually running background. And each environment is separate, right? Like this one has a restore from production here. I'm just doing a SQL command here, doing a restore, nothing magic here. My Azure one has to know how to log into Azure and do that. And I've got old steps and new steps here that these are disabled and these are enabled. And I just configure it, right? I've got variables here. So in this case, I think I've got the variables here. So I have a build password and I have a deploy password for 2 different systems that I'm trying to deploy to. I could have variables here if I wanted to, so I could override a variable and say, here is my deploy password and give it some value. I can make this secret so that it can't ever be retrieved. So other admins can come in and use this, but they would never know what the value is. It's amazing what I can do here. So if we come back to our release, that actually worked, and let's check it before we go anywhere else. So QA. So we did this and exec get 8, right? So this failed last time. We got an error and there was no results here. But if I execute it now, it actually works. Right? And again, you didn't see me touch this particular database. Everything just deployed automatically. And if I were to go look at this, I would see this stuff out there that, well, I don't want to look there, but if I look here, I'll see this store procedure, right? There's get 8, get 7. But those don't exist in my staging database. Right, these don't exist here, and if I went to my staging database still, there it is. So we did, actually just go paste that code, that's probably easier. So if we execute this, right, there's no results, and I get 2 errors here because that doesn't exist, because I haven't deployed it. Let's deploy it. So here I'll just say deploy, right? And the same process that I used essentially is happening here. Now, slightly different steps because I want to do that restore, but that's going to happen. And as soon as I do that, what I actually get here is I've programmed this for an approval. I've got a pre-approval here, which I like to have in staging because I want the DBA or operation person to be aware we're potentially going to deploy this stuff. And they have to go look at this and they get the chance to approve this. I could defer this, I could do whatever I want, but this allows me, I could go look at what this is related to in work items. I could go see the build that this is related to see what's going on here. I could perform some due diligence here to understand what's going on. Or I could just let it run, and it's going to run now. It's going to run in the background. I could certainly do things if I wanted to. I can have post-deployment scripts. So in this case, if I look at this, I have approvers here, and I'm the only approver, but I could add, who I know, like Stephanie is in the Redgate. I could add Stephanie and approve this. I could set more options so that either of us could approve it. I could have post-deployment approvers. That's a great one to say, hey, did somebody actually acknowledge they went to look at this deployment and made sure it worked by having a post-deployment approval? And I could have a condition that says you can't deploy to production until somebody's actually approved the post-deployment approval. I can send email notifications. I can do all the crazy stuff I want to do. Right? Anything that I want to do can happen. And meanwhile, this is all happening in the background. And if we come over here, I probably have code deployed to staging again, right? I didn't do anything. We restored from a previous production backup and deployed code without me having to manually go, create procedure, right, and insert into country, and all the stuff that I've done as a production DBA. Because I realized the developer forgot to tell me something, or their package was wrong, or the QA guy fixed something in QA because he realized it was broken. It was quicker to just fix it and then redeploy again. But now I could just redeploy again, right? So I could just say, let me go back to releases. I could come back here and I always have the option to redeploy stuff. So I could say, hey, rebuild a package or just redeploy it because the QA guy screwed everything up. They could just go, just redeploy all the code on top of it again, reset my environment, and let's try it again. So I have the option to do that. And of course, I don't have an approval here because it just worked in staging. I'm just going to shoot it out to Azure and cross my fingers. And hopefully that's running in the background. It is. And ideally here, again, I could be looking at this as it's running and see what's going on. But, the idea is that I have an understanding of what's going on, and I have some consistency and repeatability in my process so that I have the ability to understand what we've actually deployed and when and how. And when something breaks, we can go figure out. It's easier to troubleshoot. It's easier to look back and decide what to do. And I have complete control. We have a customer using this stuff at Redgate that deploys once a year because they do HR software. And so they deploy once a year when all the regulations change. Now, they have bugs. They might have to deploy 3 or 4 times in a week, right? Because they realize that they didn't do something correctly. But they use this process, all throughout October, and November, and December to deploy to test systems over and over and over again. And people look at it and try to decide it's working, but clients never test completely. So there's always like one thing that's broken. So when they deploy in January 1st or 2nd or 3rd or whatever day it is, and they realize there's a bug, they've got that whole process. So they can go to development real quick. Let's implement the fix. Let's deploy it back out to QA. Have somebody look at it. Did we fix the thing that's not in production? Then push it to production right away, right? That day, next day, whatever works for you. Let's see, we're finishing our release. So let's go, where's my red production screen somewhere?
Lots of people saying in Slack that they love the Octopus, have been using Octopus for deployments, and they're huge fans.
Yeah, Octopus is a fantastic, I really liked Octopus. The thing is with Octopus, I just have to run a server, and Visual Studio's team services, I don't, right? Right, the nice thing is here, like, because I travel and I do things remotely, like I just connect and I just say run agent. And it just connects into Visual Studio, and then I'm running stuff. And I don't have a server process here. I've got this really tiny agent process that's running here. But Octopus is fantastic. And as a matter of fact, if I wanted to, in the marketplace, I can never spell octopus, but I can add this to my account. I can say I'm going to install the Octopus deploy integration, and this essentially allows me to configure a tentacle on this agent that will connect to the Octopus server inside my local system and run the package there and shoot it out there and tell the Octopus deploy to do something there. When I look at the marketplace, there is freaking everything in the world here. I can send to AWS if I want. I can send messages to Slack. And we have people that do this, like when deployments happen to QA, it goes to the QA Slack channel so that everybody knows QA was updated. And when it goes to production, we have an update there. And there's Hockey app if you're a mobile guy or gal. There's everything in the world on here. It's absolutely fantastic. And Octopus is great too. Octopus has millions of plugins and it works fantastic. I'm not saying use this. Use something though. Use Octopus, use this. Just use something that allows you to automate what's going on and tell what's going on. So I've gotten this code deployed out here, and the only place I ever changed code was on this development system here on 2014. We deployed it to 2016 into Azure without having to run code manually anywhere. So let me wrap up and I'll take questions. I'm happy to take questions, but really the idea is these principles in DevOps of holistically think about everything, right? Don't think about development, don't think about ops, think about the whole thing from architects to clients and optimize the process, right? The flow, right? Some things make it harder, some easier, but optimize the flow. Use feedback loops so you understand where things are getting better and worse, and then try things, try small things, get better, write better code, do better testing, build a better process over time. The technical side of this, in most places, in a week we could set it up, but it would be really hard for your culture to understand. You'd have to start to trust it and start to figure out what all these inherent steps that you just do that you don't think about documenting, or you don't realize how many places somebody just fixes code for you. Right? You learn and get better. And ultimately, I want to treat the database as much like an application as I can. In the SQL world, our language is broken, it's hard, it's just goofy, right? It's just, there's difficulties here. But as much as possible, I want to treat it there, and I want to work around those issues like alter tables and splits and merges and renames and all that kind of stuff. And then, I've worked in a number of environments where we were SOX bound or ISO bound or something else. And ultimately, everything that you do that boils down to any process, Six Sigma, whatever it is, it comes down to, listen, do more of what works, do less of what doesn't, okay? and understand and document what you're doing, right? Understand what works, understand what doesn't, and why, and then just get better at that. And that's really the philosophy here. And so, if you're a SQL Server person, whether you want to write your own code, you want to use Redgate, you want to use Microsoft, you want to do whatever, build a process that just gets better over time. And once you get this working and you can just deploy stuff, it's fantastic. I did this stuff manually with Visual Source Safe and SQL 2000. And we did that. And when we started working, we were deploying every Wednesday. We deployed code every Wednesday for 18 months. And because we were a startup, we had to go. And when we started, me and the lead developer and a couple other developers would show up in the office Wednesday night at 8 o'clock, and we would, put stuff together. And I would run database code, and then they would run application code, and we would test it. And we spent 2 or 3 hours every week doing this. And after about 6 months, we got better. We learned to automate it, all our own automation. But eventually, it was, I called the lead developer up on Wednesday night, sitting at home, and I'm going, I run one command and it deploys all my database code. He runs a command, deploys all his app code. 3 minutes later, we're like, you good? You good? We're done. We walk away, go back to our lives. You can do this stuff, okay? It doesn't have to, I'm not saying you have to use any particular tool or method, but just do something. So there's my contact information. There's some Redgate information, but there's certainly plenty of other ways to do this stuff. And then I'll take questions.
Wonderful. So let's see here. Teddy asks, we maintain like dev, test, stage, production. Is there a canonical way to structure our databases? Like when we think DevOps, what are the normal stages that people go through?
So there's no normal thing. Because I've seen people do it in as few as 2 environments, right? Shared dev, production. Of course, I see people in production too. But
Yeah.
that's the one way I would say don't do it. I like to say at least 3 because however I'm going to do database development, I want to deploy at least once and test at least once separately from production, just to iron out any issues. Ideally, what I like to have is 5. So I want to have developers with their individuals. So this is 1 per developer, an integrated place where development can look at all the code and we can run our basic performance tests, or we can just see everything together with the app people. Then I want a QA place for sure, that somebody outside of development, whether that's clients or dedicated QA or whatever it is, can just see stuff separate from where developers might be mucking around, right? Because at each stage, I'm moving a little bit slower. And so that gives me just a tiny bit of stability. I want a staging environment. Now, I may have customers that can look at this or something else, but ultimately, I want to be able to restore from production, which means this may have to be a secure environment that very few people can see, but I just want to be able to restore from production and deploy to make sure it works. Now, I don't have to restore database. I could just restore schema, but I just have to make sure my code works because we always have drift in production. We have hot fixes. We have things that have to be fixed today, and I can't run it through the pipeline for whatever reason. Somebody screams at me to change the spelling for Porchland. I got to change that right now. I can't tell them it's going to take me 3 minutes to run it through a pipeline. It's unacceptable. So ultimately, I want to be able to restore so that if there's any weird things that have happened in production, I catch it right there. And then production. So I like to have 5 environments. I know some people go larger because they may have a dedicated perf environment where they literally do restore production. Sometimes they increase the size of production, like double it or something, and then they just hammer that with a workload and they want a dedicated environment. Some people do a training environment, so they deploy to a training environment. Some people deploy to DR at the same time. I would say at least 3. I prefer 5, and then you can go crazy, right? Whatever your budget is, go crazy.
Which is one of the things I love about the cloud is that you can stand those things up, just to go and get as many as you want for short periods of time.
Exactly. Now, in the cloud, the one thing to be careful, database DevOps stuff, is that if you've ever tried to create a database in Azure, it could go probably like that, right? Not super fast, but seconds. It could take minutes or tens of minutes. So you may need some timeouts or things. Yeah, be careful, right?
C2 says, how about changing column order? Is it easy enough to, using stuff like the Redgate tools or anybody's tools, can I change column order, or should I just always add new columns to the end of a table? Okay, so that gets into a database design philosophy, and I'd be curious what maybe a Karen Lopez might say, but I think if you worry about column order, you're a moron. I'm sorry.
You're getting caught up in the detail. It's irrelevant to the world. You shouldn't care about the physical order of columns. If you ever do anything like I'm addressing columns in a certain order or something, you're fundamentally misusing the database there. Now, if you care about columns for report writers or something, make a view. Not terribly difficult, right? But for CRUD applications, for stuff, you should never worry about column order. If you ever address columns as bracket 1, bracket 2, bracket 3, you are digging a hole that you will never get out of.
Joe has a point that I'll give him in Slack, and I hadn't thought of this, which is replication. So it can matter deterministically if you're creating objects on either side in replication, but I just don't.
But that's disorganization, right? Like, so you've got to have control of your replication environment in some sense. Now, replication has all kinds of issues, right? It's to me, that's like the huge failing in the SQL Server platform because it's so brittle, right? Phenomenal technology. Like, I love replication, but it's just too brittle in SQL Server. And so I'm an add guy in general. Like, we add things and then we clean up later. So there are changes that take place across time. There's a domain of problems like a column split or a column merge or table split, table merge, horizontal partitioning, all these problems that really should take place across time, because you don't want to split a column 1 into 2, right? Like address into street name and street number, and then delete the address, because I guarantee you there's 8 places in your code you forgot you talked to that column. So what you do is you add, I have a trigger that syncs things, right? 1 or 2 triggers. And then across days, weeks, I figure out where things are broken. And eventually I turn that off and I delete it. And the same thing with replication. Like, replication is, you've got to have slow change and you've got to be careful, you know. But this is a great way for replication, because what do people do when they deploy replication a lot of times, right? Pause things. Some people just go, you know what, I'm freaking scrapping replication and we're going to script it and reset it up when we're done, because it's easier. And so the way to do that is build that into your process so that it always works the way that works in your environment.
So the great question in Slack is the one other place where it matters is if I have developers who do insert table and they don't name the fields and then select.
So this is how you fix that, right?
No, I like Jorge Segarra. SQL Chicken had a great way of fixing that. He said add a computed field with 1 divided by 0 or something like that in it. So then they can't do a select star. They can't do inserts without.
There's any number of ways to do it. I mean, to me, that's a technical debt issue that you don't want to have, because that prevents you from making changes around. So if you write insert table select, then I don't deploy your code. Right? And then we can go have the argument in front of somebody else about why this is just fundamentally bad. And if you can't figure out how to use SQL prompt or to drag the columns from the left side of Management Studio into the column window and store that code, then maybe you're not cut out to be a database developer. You know, I mean, sometimes I think you gotta draw lines, because you're just making bad decisions.
And SQL Gene asks, he says, and we discussed this in Slack, but I think it should be on the recording, is how do you write good unit tests for SQL? And he'd never seen T-SQL-T. He said, good unit testing should avoid side effects and state mutation. How do I unit test things like stored procedures?
Yeah, so it's hard. I mean, testing is an art, and the thing you'll do is you'll write tests that are good and you'll write tests that are bad. And one of the things I see with developers, all developers, and Richie probably was a good one to ask, is that it's so hard to get used to throwing away tests, because you realize I wrote a bad test. You know, but once you've written it and you've started to use it, you're like, I don't know. So here's what test I have. In this test is I'm testing that I'm calling a function and I'm updating the table in this test. And so one of the things I do is I reset, I create an expected result table, right? So this is kind of like what I expect to get in my assertion. Here I'm going to add some data into a table. So one of the reasons what T-SQL2 allows me to do is copy a table and empty it and fake it so that I can muck with it however I want. So in this case, I add data to it. I add data to my expected result, because what I want to do is eventually compare 2 tables. Here, this is a function that is in my stored procedure, but I don't want to call a stored procedure that calls a function and test that, because I want isolation, right? I want to stub and mock and isolate things down. And so one of the things I do here is this allows me to replace this function call with my own function call. So in essence, this function is just a returns a scalar value in this case, but I'm taking all the calculation stuff out of the function here, and then I call my stored procedure, right? And if I were to look at this code, let's make this bigger. Right here, what I'm doing is, I get a variable, I get a parameter, I'm testing some error handling, I call this function and get a value back, and I do an update. So that's my function, or my stored procedure. And here what I'm doing is just testing it, and then I'm just creating an assertion. And once you learn about testing, we do a lot of assertions, right? We do assertions all sorts of places in computer science. The OS does assertions all the time because it goes, if checksum of value red doesn't equal what I think it is, I get a blue screen of death. The blue screens of death are assertion failures in the operating system where it goes, I don't know what's going on. I'm not doing any more work. Right? And process failures that we have sometimes when processes just explode, it's because they hit an assertion point. Now, if they're bad developers, it's because something just exploded in memory. But good developers have assertion points all over. And that's all we're doing with testing here. I have other tests like this test is I'm looking for my table is my metadata. So here what I'm doing is I'm saying, my table is my API. Here I'm saying this is what this table has to look like. And if the fundamental table changes, right, here I'm doing a select star because I'm just comparing metadata. If that changes, I fail this test, not because we can't change a table, because if somebody changes this table, this has 1 billion rows in it. I want every single person to know that this table changed, and it's potentially going to cause us issues. And so then we have a conversation. And there's ways to write tests. Like, one of the things I have, like we have SQL cop tests, like I have tables without a primary key. I look to see if there's a primary key on this table, right? We look at sys objects, sys schemas, and if there's no primary key, we fail a test because you always have a primary key. But there are very rare cases you don't have a primary key. And if you can prove to me that's the case, I'll add an extended property with an exception to my test.
Oh, funny. Okay.
Right. So I have some ways of writing tests that allow me to do things. Right. In the database world, we often want to test 0 rows, 1 row, or multiple rows because those are common issues we may have with queries or inserts or things. We may want to write tests that look at, I have to do something outside, like I call a CLR procedure, I send an email, whatever. I want to mock those out, and there's ways to mock those out. We may want to do boundary conditions. So in e-commerce, we have discounts at 5% and 10%, and so we have to decide, is it 5% or 5.001%, right? And we want to test those boundaries and make sure that we're implementing code according to what is expected. So if we get to the production and we get to the test and the client says, no, it's 5.01%, not 5%, we can go look at the test and say, well, you said 5%, so that's the test. That's the documentation of the spec. Which one do we change, right? Do we change the test, change the code? We figure that stuff out. So those are kind of the ways you do testing, but testing is an art, and you got to practice writing tests. So you got to, like I said, somebody tells you did something wrong, write a test.
Especially, now you see how the level of complexity involved with it with SQL Server code, because like he said, it is all state mutation, which is...
Yeah. The other thing is, you like to work on limited rows of data, right? So almost all tests could probably be done with less than 30 rows of data. And I love that because the last thing I want to do is I want to test an island function with windowing aggregates across 1 million rows of data. I know you love doing it as developers, but trying to figure out if I've actually calculated stuff correctly and then waiting for that to run when I've written a cross join and made a mistake, God, that's maddening. Yeah. So I write tests. Like I write tests all the time. Somebody says, how do I find the gap in this set of identities? Well, write a test that creates a gap, run the test, and it's going to fail. And then you write a query that goes, all right, let's calculate that. And it should match your expected results. That's what it is. That's what I'm doing here is I'm saying, here's what I expect. I expect 1 row of data from the result of this query. I could expect 5 rows, 12 rows, whatever. But I just put those down. All I do is formalize it into a test so that I'm not trying to, scroll through Management Studio and go, did I get the, account balance correct?
I'll even look at some of the new cutting edge development type stuff that's doing continuous testing in the background as you're typing. I look at some of the stuff, Richie. I'm like auto testing while you work. I'm like, dang, that's just another whole level.
Yeah, it is. I mean, Visual Studio 2017 does that, and to me, it's slightly annoying because a lot of times I'm mucking with code, right? Like I'm trying a method and I'm going, what do I think I want to do here? And so when it's constantly going, you failed, it's
Yeah.
it's slightly
Give me
maddening.
30 seconds.
Yeah. Yeah, but I mean, I just do development, right? And then I just say, here, let's just run that run all, I just run these periodically. It helps if I spell things correctly. That usually makes things work better. But I just run tests, and then I can just see. And Redgate has a plugin to do this, right? That all it does is it runs that command. That I'll just come in here and I'll say, well, I just want to run this one test, and it'll run it and tell me if I failed, right? And I think the primary key one will fail. But I can do all this stuff in the command line. I could do it, any number of ways. I just want a way to repeat it over and over again. So as I'm testing my query and trying to figure it out, I just want it to run, right? And I'm sure you did this with SP Blitz, right? Like, did we actually get the DMV that gets, the degree of parallelism or whatever, right?
It's really funny that I'm a huge believer in unit testing and T-SQL testing now, but all the SP Blitz, SP Blitz Cache, none of those have any testing at all. And I feel the pain every time we go do a new version. I know there's checks in there that don't work. I'm absolutely positive.
And the thing is, like, I wouldn't go write all the tests, right? Like I'd go, all right, we're going to add a function for X, right? So let me just, I'll just create a new test, whoops. And I'll say, test X. And then I'll just write the code, right? I'll just go and say, all right, select star from sys.dm underscore blah, blah,
Yeah.
Right. And then, I'm just doing an assert, right? I'll assert this equals some value, and then I never have to go check that particular thing again because it's codified. This is what I'm trying to assume works.
Yeah, and it's the same with any new stuff that we develop. And Richie, I'm sure, is watching this. He was talking in Slack. I'm a huge believer of start with the tests, and he's a visionary on that.
I mean, you can do the SP configure. I'm going to change it. I can look for negative tests. I can look for exceptions. I mean, I don't love test-driven development because to me, a lot of times I'm not quite sure exactly how the spec should work, and sometimes I have to futz with it. But I often write some code. Like if I'm writing this code, let me find that function real quick. What I may do is come in here and go, all right, this is how I think this should work, which is actually horrible code, but it's there for a reason. And then I may write the test that says this works. And then let's do something like, let's change this to 20. And I'll recompile this and run the test, and the test should fail. And then I'll come back here and I'll go, all right, do that. And then eventually I'll go, well, really, this is dumb, right? And what I really want to do is something like, I want to take the len of this, and this is more efficient code, right? So, but the test should still pass. If I refactor this code, the test has to still pass, right? And that's what it is. Testing is often about avoiding regressions, not breaking stuff that worked last time.
JD says, without validated requirements, what are we testing? This is why I'm skeptical about test-driven development.
So JD, you always have requirements, right? Whether they're imaginary in your own head or somebody wrote them down and gave them to me, you've got requirements. I mean, the classic one, this is the thing I see all the time where somebody will go, I need to insert into country codes. And I think this is valid, right? Like I think this always works, right? And so what I'll do is I'll do select star from country codes, and then I'll do this, and I'll do select star from, and I'll go, this is a test, right? Because in my head, this is perfectly valid. The problem is, whatever I put in here, right? If I take that example we had, and I run this test, it'll work great, and I can say, my code works. And then tomorrow somebody goes, well, are you sure this works? If I run this test again, it doesn't work, right? Because now I've duplicated things. I don't know, I'm not testing. How hard is it for me to just go, really, let's get rid of this. Let me spend 8 minutes writing the test that tells me in my head I expect an insert, and then go dot run, and I'm going to say this will be country tests dot test insert into country codes, or however you spell that. And that's my test now, right? And instead of having this stuff, all I've done is I've codified that according to what I believe. So it doesn't matter if somebody else gives me requirements. I've still got to make decisions as a developer of how I think it works. And for me to write tests to go, this is how I think it works. Then later on, when somebody yells at me, I can go, well, this is what I thought you said. And I've got some documentation rather than some random set of test stuff that I ran, last Thursday, and I think I remember what I did.
Yeah.
That's all we're doing is we're just codifying what you believe.
Well, it was perfect. Great session, sir. Lots of interactivity in Slack. You should go through and read the messages because lots of people were talking back and forth about things like Octopus. Thank you for speaking today.
Really pleasure. Thank you.